Hello, this is Mathematics, and today we are back on roots of polynomials. Today we are doing expressions relating to the roots of polynomials. So let's get into it. So in the last video, one of the questions had 1 over alpha plus 1 over beta plus 1 over gamma. I'm just going to generalize it here for a quartic, because it's like the maximum you can get. For Edexcel A level further maths, they only give it to a quartic. So if you've got like the sum of all the individual reciprocals of the roots, all you do is to play around. So you add these, like using your algebra and everything, and you just add it all together. And what you find out is it will give the sum of the triples divided by the product of the roots. In this one, because it was a quartic, we got the sum of the doubles over the product. For a quartic, it's the sum of the triples over the product. And it becomes negative d over a. For a quartic. If we have this sort of thing, where we've got alpha to the n, beta to the n, gamma to the n, delta to the n, we can just, I guess, like factor the n out, like the indice, and what we get is alpha, beta, gamma, which is the product of the roots, all to the power of n, which is just e to the n over a to the n, or just this. There are some identities which are useful to know. I should put an identity over here, and an identity over here. Alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. That's simple, because I mean, like, if you imagine alpha plus beta all squared, that's just alpha squared plus 2 alpha beta plus beta squared. So if you just want alpha squared plus beta squared, you're just going to minus this, which gives you this. For the cubic, it's a bit more complicated, but again, you can do the same thing. You work out this, extract this from it by subtracting all of this. So these are just useful identities to know. Alright, well, let's get into it. So the main thing is expressions relating to the roots of polynomials. They will always end up being the facts over here. All you have to do is play around with them first and simplify, and then you will find out what you have to do. Okay, so this first question over here. The 3 roots of a cubic equation are alpha, beta, gamma. The product is equal to 4. The sum of the doubles is equal to negative 5. And the sum of the roots is equal to 3. Find the value of alpha plus 3, beta plus 3, gamma plus 3. Okay, well, alpha plus 3, beta plus 3, gamma plus 3. Like I said, play around with it and simplify. We're going to expand. So if we expand the first 2 brackets, we're going to get alpha beta plus 3 alpha plus 3 beta. Actually, yeah, plus 3 alpha plus 3 beta plus 9. We are now expanding all of this by gamma plus 3. When we do this, we get alpha, beta, gamma. So we see we've got our 4 plus 3 alpha beta plus 3 alpha gamma plus 9 alpha. I'm just going to continue expanding all this, so then we get plus 3 beta gamma plus 9 beta plus 9 gamma plus 27. Okay. We can do some factorizing. Which equals alpha beta gamma. If we factor out this 3, we'll get 3 lots of alpha beta plus alpha gamma plus beta gamma, which is the sum of the doubles, so we get plus 3 lots of the sum of the doubles. If we factor out the 9, we get 9 alpha plus beta plus gamma, which is just plus 9 lots of the sum of the roots, plus 27. Okay. Well, we know that alpha, beta, gamma, they told us is 4. So we're just going to get 4. And then sum of the doubles was minus 5. Multiplying it by 3. So we're going to get minus 3 lots of 5. Plus 9 lots of 3, which is 27. And then the plus 27 on the end. And working out, this gives us 43. So, the first question should be 43. We'll check on the answers. Put it to the front. And yeah, 43, 43. They've just done everything. So they expanded the brackets and then grouped the terms and factorized exactly like we did. Okay. Actually, I'll just put that back. Alright. Now this question. I have got this question on my TikTok actually, for a post that's a bit further down. Parts A to D are fine. Well, actually, parts A to C are fine. D gets a bit, you have to think about it a little bit, and E is just horror. Let's just do it. Okay. Part A. Here we've got a similar sort of thing. Here we just had alpha plus 3, beta plus 3, gamma plus 3. Here we've got alpha plus 2, beta plus 2, gamma plus 2. Just go ahead with the expanding. So when we expand all this, you can kind of like figure out what it's going to be, because when we had it all plus 3, it became this. When it's all plus 2, it's going to probably be alpha, beta, gamma plus 2 sigma alpha beta plus 4 sigma alpha plus 8. Because like, this is just 3, this was 3 squared, this was 3 cubed, so we're going to have 2 squared, 2 cubed. Okay. Well, this is going to be alpha, beta, gamma, we are told is -2/5, plus 2 lots of the sum of the doubles, which we are told is 3/4, plus 4 lots of -1/2, and then plus 8, which on our calculator is, which gives us 71/10. Okay, so that's part A. Okay, now part B. Now, this one, that's risky because you can easily make mistakes, so I'm just going to expand out part B normally. So alpha minus 3, beta minus 3, gamma minus 3. First one is going to be alpha beta minus 3 alpha minus 3 beta plus 9, multiplied by gamma minus 3, which is going to be alpha beta gamma. Then we're going to get minus 3 alpha beta, minus 3 alpha gamma, minus 3 beta gamma. So we're going to get minus 3, the sum of alpha beta. And then the individual roots, we're going to get 9 alpha, 9 beta, and then 9 gamma. So plus 9 alpha, beta, alpha plus beta plus gamma. Oh, let's go over here. So plus 9, sum of the individual roots. And then the final term will be 9 plus 5, which is minus 27. Okay, well this is equal to alpha beta gamma was -2/5, minus 3 lots of the doubles, which was 3/4, plus 9 lots of -1/2, minus 27, which is equal to minus 683/20. Okay, so that's part B. Part C now. 1 minus alpha, 1 minus beta, and 1 minus gamma. Okay, well this is going to be doing the first bracket, so we're going to get 1 minus beta minus alpha plus alpha beta, and then 1 minus gamma, which is again 1 minus gamma minus beta plus beta gamma minus alpha plus alpha gamma plus alpha beta minus alpha beta gamma. Okay, so this gives us 1 minus gamma minus beta minus alpha is just minus the sum of the roots. We get beta gamma, alpha beta, that's just plus the sum of the doubles. So that's these terms taken care of. And we get minus alpha beta gamma. Well, that is just 1 minus half, which is plus half, plus alpha beta, sum of alpha beta, which is plus 3/4, minus alpha beta gamma, which is minus 2/5, which is plus 2/5, which is 53/20. Okay, that's the answer. Okay, that's the answer for part C. Okay, now part D. This is where some thinking comes in, and then part E is like the final boss. Okay. Okay, part D now. Right, now this is different. In the thing over here, we had like alpha squared and beta squared, and then we had alpha cubed and beta cubed and everything like that. So we had like individual roots raised to powers. Here we've got the doubles raised to powers of 2. Well, you kind of just really have to think about what to play around here, because it's really weird. Well, like for this example, when we had alpha squared and beta squared, we looked at alpha plus beta all squared, and then we like rearranged it. And again for here, when we had alpha cubed and beta cubed, we looked at alpha and beta all cubed, and then we rearranged it. So if we've got this squared plus this squared plus this squared, maybe we have to look at all of this squared and then rearrange it. So let's look at alpha beta plus beta gamma plus gamma alpha all squared. When we expand this, okay, well this is just 2 lots of these brackets, and now we're just going to have to expand all of this out. Alright, well this will be alpha beta all squared plus alpha beta squared gamma. Okay, I'm just going to go ahead and do all this. Plus So I've expanded all this, and we've got all of this. Okay, now we can extract the terms that we wanted. But first, let's do some simplifying of all this over here. So what we've got is we've got our alpha beta all squared, plus our beta gamma all squared, and then our gamma alpha all squared. Well, when we look at our terms over here, what we see is we've got like two of each term. So we've got alpha squared beta gamma and alpha squared beta gamma. Alpha beta squared gamma, alpha beta squared gamma. Alpha beta gamma squared, alpha beta gamma squared. So when we factorize this, we just get two lots of alpha beta squared gamma plus alpha squared beta gamma plus alpha beta gamma squared. Well, again, all of these have at least one alpha beta gamma in them. So this just becomes all of this added to 2. Now if we factor out alpha beta gamma, what we are left with is beta plus alpha plus gamma, which is our sum of individual roots. Okay, so that must mean that all of this is just going to be this minus this then. So therefore the thing that we want, alpha beta squared plus beta gamma squared plus all of that squared, is identical to all of this minus this. You can see that was a lot more work than the others. Well, now we can just substitute numbers because we know that the sum of all the doubles is 3/4. So we're going to square that, and then we're minusing two lots of the product of the roots, which is negative 2/5, and then by the sum of the roots, which is negative 1/2. And this gives us 13/80. Right, so that's part B done. D done. Alright, now the final boss. By the way, I think stuff like this it hasn't ever come up on the exam. Only this sort of stuff has, and then like stuff like we've got alpha squared and beta squared, or like all of them individually, like they're all individually raised to a power. I've never seen anything like this before because it's just too long. There's no way you're going to think like that in the exam unless you're like a super genius. Alright, so the same sort of idea here. Here we've got them all cubed. So let's look at the sum of all of them cubed. So let's take a look at alpha beta plus beta gamma plus alpha gamma all cubed. Right, this is going to be this bracket multiplied by itself 3 times. Okay. Without any further ado, let us get to expanding. Okay, so after expanding all this out, we get alpha beta cubed plus this plus all of this. It takes 2 lines. Okay, more simplifying is equal to. Oh, Alright, sorry. What we're now going to get is the stuff that we want. So we have alpha beta cubed plus beta gamma cubed plus alpha gamma cubed plus. Okay, so I've got somewhere. So we've got the 3 terms that we want, and then we've got a load of this stuff over here, which I'm sure will simplify nicely. And then what we find is we get 2 alpha beta gamma, alpha plus beta plus gamma. And then like it's the same over here, except here we've just got like the doubles. So I'm sure with some factorizing out the 2 and then this, we're just going to get 2 alpha beta gamma, sigma alpha beta, hopefully. Because I'm sure that will hopefully work. Okay, yes, so we've got 3 terms over here, and the factorization I said earlier, and now we can factor out an alpha beta gamma from all this, and then we just get this. I think we can kind of group these, hopefully, and it will give us something. So we get okay, so we have like collected some like terms, and then we factor this. So now I'm just seeing what on earth we can do. Okay, well it's still going to be okay. I think we have to be very, very, very sneaky here. We've got doubles over here, which hopefully we could factorize out, but we need stuff to be common in here. Like it's almost common. Here we've got beta and a beta. There's an alpha and an alpha, and a gamma and a gamma. They're all just missing one thing. And if we were to add one thing to all of those, it would just give us the alpha, beta, plus gamma in each bracket. So let's try and do that. If our first one, alpha, beta, we add a gamma into there. Beta plus alpha plus gamma. Because we have added a gamma term, we have to also subtract that. So we've got alpha, beta multiplied by gamma, which will give us alpha, beta, gamma. So we have to subtract that as well. So subtract alpha, beta, gamma. Likewise, if we do the beta gamma, and then we add an alpha in this bracket, we again have to subtract alpha, beta, gamma. Likewise, with the alpha gamma bracket, if we add a beta in there, alpha plus beta plus gamma, we again must subtract alpha, beta, gamma. Now, this is towards the end of alpha. So what this becomes is all this cubed plus alpha, beta, gamma, open brackets. Sum of the roots are all common. So if we factor out some roots, we will then be left with alpha, beta plus beta, gamma plus alpha, gamma, which is just the sum of the products and of the levels. And then we've got minus alpha, beta, minus alpha, beta, minus alpha, beta, gamma, which is minus 3 alpha, beta, gamma. And then we have this 2 plus 2 alpha, beta, gamma, and so on. Yes. Alright. I think we are definitely done now. Remember, this is all equal to this expansion over here. So that means that this must be equal to this whole expansion minus all of this. So, therefore, alpha beta cubed, all of that is identical to alpha beta plus beta gamma plus alpha gamma all cubed minus all of this. Okay. All this is, we know that the sum of levels is 3/4. That's 3/4 cubed minus alpha beta gamma will do this. The sum of the roots will negative half. The total is 3/4. Alpha beta gamma again was negative 2/5. Plus 2 also negative 2/5. Sigma alpha was negative half. And then sigma alpha beta was 3/4. Okay, so now at the end of that, at the end of all of that, we get this. And now we can just work out in a calculator, which gives us 723 over 1,600. I had to recalculate it like 5 times because there's so many brackets. Because like you had to do this cubed minus all of this. So finally I think the answer is 723 over 1,006. Exercise 4D, question 6. Oh, so question 6. So part A we got 71 over 10. Yep, which is what we got over here, 71 over 10. Part B we think was minus 683 over 20. Yep, minus 683 over 20. Part C we think was 53 over 20. Yep, 53 over 20. Okay, now part D. You can see all the working, but we think it was 13 over 80. And we got, 13 over 80. Okay, now part E. You can just see, look how that looks. Just look at all that working. That looks that's an absolute monster. But we think it was 723 over 1,600. Let's see. Oh my gosh, look at the working for part B. It just goes down one column, another. But yep. Whoops. What the hell happened there? And they also got 723 over 1,600. Look at all that working. It goes across like 2 columns. Part E, and then it finishes there. But look how beautiful that is. 723 over 1,600, 723 over 1,600. But just look, I've done this question before, it's on my TikTok, so I knew the method. But if that comes up as like a 6 marker in your exam, this is not taking 6 minutes. And you're saying you're not going to make a mistake in all of this. I made a mistake while calculating it. You can get it all right and still get it wrong by calculating all of this wrong because of all the brackets. You need to subtract all of this in brackets. But it's just testing like the best further math students among you all. Okay, well, we are done with this now. Expressions relating to roots. Oh, I even left another page, but we're just too good. We didn't need it. Okay, and next we are on to the final section, which is linear transformations of roots. Okay, thank you for watching. Hope this was helpful. Goodbye.